In previous few lectures, we have already solved some numericals on finite duration discrete time sequence, Z transform of finite duration discrete time sequences. Today we will determine the Z transform and region of convergence for infinite duration sequence, discrete time sequence. Now here we have taken one example, x of n equal to a to the power n u of n, where u of n is the unit step function. So before determining the Z transform and ROC for infinite duration sequences, we need to know few formulas on GP series. Now here are the formulas for GP series. The first one is r to the power 0 plus r to the power 1 plus r to the power 2 up to r to the power infinite is always equal to 1 by 1 minus mod r, where mod r is less than 1. This is infinite GP series. The second one is this GP series is for finite duration, and it will start from r to the power 0 to r to the power n minus 1, and it will be 1 minus r to the power n minus 1 plus 1 divided by 1 minus mod r, provided mod r is less than 1. The third one is r to the power 0, r to the power 1 plus r to the power 2 up to r to the power n. The maximum value is n, and the formula will be 1 minus r to the power n plus 1 by 1 minus mod r. Again, mod r is less than 1. Next one is, if mod r is greater than 1, then the GP series will converge at r to the power n minus 1 by r minus 1, if the highest value is n minus 1. And the last one is, if the highest value is capital N, or the GP series will start from 0 to n, then the formula will be r to the power n plus 1 minus 1 by r minus 1, provided mod r is greater than 1. So these are the few GP series formulas which is going to be used in our Z transform numericals. So let us solve this question. Now we know Z transform of x of n is always equal to x of z, which is equal to summation n equal to minus infinite to infinite x of n z to the power minus n. Now x of n equal to a to the power n u of n, where u of n is a unit step function, and we know a unit step function u of n is equal to 1 for n greater than equal to 0 and is equal to 0 for n less than 0. So this is the functional representation of unit step function. Graphically, you can say if x-axis is n and this is u of n, then it will be one at 0, 1, 2, 3, 4 up to infinite, and for n less than 0 the output will be 0, and these are all finite values, which is 1. So this particular function x of z is equal to summation n equal to minus infinite to minus 1 and 0 to infinite. The whole summation can be divided into two parts, one from minus infinite to minus 1 and another from 0 to infinite. And the function is a to the power n u of n z to the power minus n, and this one will be a to the power n u of n z to the power minus n. Now the unit step function is equal to 0 from minus infinite to minus 1, and unit step function u of n equal to 1 between 0 to infinite. So this can be written as x of z is equal to summation n equal to 0 to infinite a to the power n z to the power minus n, and u of n equal to 1. N is equal to 0 to infinite a to the power n z to the power minus n. Now a GP series always has a positive power, so we need to bring this function in the form of something to the power n. So what we will do, we can write this function as n equal to 0 to infinite a z inverse whole to the power n. And now we can apply the formula for GP series. A z inverse to the power 0, a z inverse to the power 1, a z inverse to the power infinite. And we know a GP series converges at 1 by 1 minus mod of a z inverse. A z inverse must be less than 1. So this particular result is the z transform of the function a to the power n u of n, and the region of convergence can be determined from this condition. A z inverse is less than 1, or you can say a by z is less than 1, or finally you can say mod z is greater than a, where a is the radius of the circle and z plane. So this is the z plane, the real axis of z, imaginary axis of z, and hypothetical infinite rectangular box. Draw a circle with radius a, or you can say it has a pole equal to a. The ROC is mod z greater than a. So we will do shading of the region greater than a, or you can say the region exterior to the circle with radius a is our ROC. So in this way we can determine the z transform, and we can plot the region of convergence for an infinite duration sequence. Now one more thing, this particular sequence is a Causal sequence because u of n is finite for n greater than equal to 0 and is equal to 0 for n less than 0. And as per the definition of Causal sequence, we know a Causal sequence is always finite for n greater than equal to 0. So our z transform x of z is 1 by 1 minus a z inverse, which can further be solved as z by z minus a. Thank you.